And now we get to hear from Kevin Bates. Kevin is a developer, works in the San Francisco Bay Area, Silicon Valley, and the most exciting thing is this is a developer that's actually figured out how to do zero net energy buildings and make a profit from it. So I think a lot of people want to hear how he gets that done. Thanks, Kevin.
All right, we'll see how that goes.
I'll switch seats over here.
So this is a picture of the most recent building we just finished in Sunnyvale. This is a 40-year-old concrete tilt-up, which is kind of what we specialize in, building that was a racquetball court with no windows. This looks like a uncommonly intelligent group, so I'm not going to read any of these slides to you. That way we'll get twice as much information in a quick way. So the question really here is what I'm going to try to do is arm you with some information, those of you that are engineers, architects, and whatnot, trying to convince your clients to push things in the sustainable net zero energy way, give you some information and some ammunition to help with that discussion and help inform that. These are the typical questions that, or objections that developers and owners like myself have to pursuing net zero energy. It's too expensive. I don't know how to do it. What if it doesn't work? All of those kinds of things. I guess I need to leave this up for a second to see which one's most important to you. Because what I'm going to try to do today is speak to each of these objections a little bit and then briefly tell you some methodologies of how to do this in a cost-effective way so it can actually be profitable for you. And based on what the readings are coming up, I would have guessed the entire audience were developers, even though they're not, because that's what I would say. Okay, it's too expensive. So I'm going to speak to all this. This is kind of a list of objectives we have that we drive our buildings to in the design process. And I'll let you read them yourselves, but basically it's net zero energy, it's carbon neutral, we cap off the gas line, and we're doing this with a very, very strong emphasis on the health and wellness of the occupants that are going to eventually occupy this building and inhabit this building. And then the most important is the bottom one, where we've got to do this more profitably than the less expensive way of building to meet minimum code. It's never going to resonate in the private sector unless you can do it more profitably. So let's talk about that first objection that was the most important to this group. Renovating is too expensive. So these are actually empirical actual numbers. I took a case of, we're on our 4th building right now, and I took these numbers come from the very first one we did because we've now got actual expense numbers, actual performance numbers, and know exactly what these numbers look like because we've had it occupied for about 18 months now. So when we did this building, we hard bid the cost as though we were going to build it to meet minimum code. We kept those numbers and compared that to what we actually spent to drive this building to net zero energy and highly sustainable for the occupants. That cost us $49.84 a square foot more. That drove our operating expenses, which includes everything. It's power, it's gas, it's water use, it's reserve requirements, it's all of those things. It drove those maintenance numbers, all of that down about 45 cents a foot, which in today's current cap rate, the way we value buildings and value income stream, we picked up about $83 a square foot in value. Then there were some other things that we weren't expecting. We didn't know how it was going to go, where the building leased more quickly than the market average, and it's significantly higher rents than the market average. And that was a direct equation and a direct result of these types of buildings ended up being very highly desirable in the marketplace. So the result of all of this is, had we sold this building the day after it was occupied, we would have made $100 a square foot more than we would have had we built it to meet minimum code less expensively. And so I think most of the people here, if I pulled $3 out of my pocket, $3 bills, and say, give me a dollar bill, and I'll give you these 3, most of you would do that deal. The problem we're having is developers and owners, all they're hearing is, give me that dollar bill. They're not hearing and they're not looking at, they're going to get 3 back. So I wouldn't know where to start. I don't know how to do it. I'll let you guys read this. But basically what we do, in order to do this cost effectively, you've got to drive and take as much of what nature gives you for free and then make as many of your building methodologies serve multiple purposes as possible. So for example, we try to drive that EUI down, that's HVAC use, that's artificial lighting use. Those are the biggest loads that we have to deal with. So for the HVAC piece, we'll insulate the outside of our building. What does that do? I get the thermal R value that I want on the insulatory piece. I've reskinned my building because I have a whole new look to it now. I've actually increased the size of my building that's leasable square footage because that insulation is about 6 inches thick, which doesn't seem like a big deal. But when you capitalize the rents we actually achieve on these buildings, that extra square footage pays between 80 and 87% of the cost of reskinning the building and re-insulating. So all those little things add up. The most important thing is it leaves my thermal mass inside exposed. All my concrete is exposed, and that's what acts as my air conditioner. That first building we did that's been occupied for 18 months has yet to have the air conditioner go on. That thermal mass is an incredibly efficient heat sink. It absorbs the human heat, the computer heat. At night, we have electrochromic glass windows that open, the skylights open, the fans go on when the temperature drops outside. That draws the air down, and we cool that thermal mass, that concrete, down to the temperature we want to start the next day again, where it's ready to start absorbing heat. So that drives down our HVAC numbers, which I'll show you in a minute. And then for the lighting loads, we developed a skylight ourselves because there wasn't anything on the market that did what we wanted. And we engineered that so that the angle, the aperture, the orientation, the shape of the shell, they're southward facing, which is very uncommon. All of that is to maximize the harvesting of daylight 365 days a year while minimizing thermal gain. It's exactly where those vectors cross. This is what ends up happening to our HVAC size. Again, I said the AC has never been on in this building. We use this mostly for air exchange, is why we need this size. So we're about 20 tons of equipment on a building that used to have 100 tons of equipment. So now my first cost went down, my maintenance costs go down, and my reserve requirements all but essentially go away because I'll never have to replace this unit. And by driving that EUI down, it also drove down, we drive that down to about 25% of what it was. That drives down my PV array 25%. So that whole first cost, if I was going to have to do $1 million solar array, now that's $250,000. On the lighting side, this is a picture of this building we've been talking about with no lights on before we did the renovation. This is a picture at the same time of day, that same building with no lights on after the renovation. So I don't know if I can go backwards, but that's the difference in free light. All that was free. Nature's given us that. That's before and that's after. We get 19-foot candles on average of light on the 30-inch work surface in every square inch of this building from an hour after sunrise to an hour before sunset, 365 days a year. We don't have any artificial lights on. So in wrapping all of this up, what if it doesn't work? It's too risky. Well, we've got our thermal comfort and our lighting, our two biggest loads, are now being delivered by a much more reliable source than we had before, which was PG&E. Sorry, Peter. But just saying, our dependability's gone up. And so we're getting all that. We have much less equipment to maintain. We have much less equipment that has moving parts that could break down. We now have occupants operating in buildings that are operating under natural light, cleaner air, better acoustics, with 24/7 connectivity to nature. So you've got happier, healthier, more productive employees. More productive employees translates into a more profitable tenant, more profitable company. And so if you go back to the earlier slide, you've got happier, more productive employees, more profitable company because of this, and as the building owner, we already talked about how we're more profitable as well. So we're really having a hard time figuring out why you wouldn't do it this way. And last but not least, it's the right thing to do for the occupants that are going to be in these buildings 8, 10, 12 hours a day. And it's the right thing to do for the environment. So that's what I've got on that.
All right.